Oh, good day, good day, good day. Today, very quickly, we're looking at what happens when two or more charges touch. Okay, so very briefly, we are going to apply the principle of conservation of charge, which you would have learned in grade 10, yes, or maybe grade 11. Okay, grade 10, but you are expected to know this in grade 12. But when you look at the curriculum for grade 12, it may not be very explicit. You are required to know this. Not that very well. So when charge is charged, basically they share the charge. But we are going to start with the principle of conservation of charge. This says if you look at this as a system, the total charge or the net charge remains constant in any physical process. That's the principle of conservation of charge. And the formula now to find the total charge would be Q1 plus Q2. If there are more, Q1 plus Q2 plus Q3, right? So in this case, this was plus 1 microcoulombs, this was minus 5. So you just add 1 plus minus 5. And in this case, the sign of the charge is very important. Remember, when you're doing Coulomb's law, force, or when you're doing the electric field, you don't put the sign of the charge in the formula, please. You remember that grade 12. So plus 1, plus that gives you negative 4 microcoulombs. So this will be my total charge, the minus 4 times 10 to the power minus. So which means when they charge, the total charge remains Q1 plus Q2. So what you are required to do in the exams is to add, and then if there are two, to get the charge after they're separated, you divide by 2. So it's going to be that answer. Let's just write the formula straight. It's Q1 plus Q2 divided by 2 because they are 2. If there were 3, it would be Q1 plus Q2 plus Q3 divided by 3. Please note that grade 4 so that you are not caught unaware. So that will be that divided by 2. That will give us, each one will be negative 2. Remember, minus 4 divided by 2 will be, so negative 2. This one will be negative 2 microcoulombs, negative 2 after the microcoulombs. And this one will be negative 2 microcoulombs. Now, the other part that they ask is, how much charge was, this one was positive, is now negative. And the interesting thing is the two charges after separation, they have the same charge. So the answer for this is also equal to the answer for that. So QA is minus 2 microcoulombs, which is also equal to QB after. Remember, the initial is that one, the after is this one. So if you want to calculate now the change in charge, put it right at the top there, I'll remove there. The quantity that they call change in charge is going to be, I call this one change delta Q in charge is equal to, you can look at each charge separately. Is final charge minus initial charge. So if you look at A, final charge of A minus initial charge of A. Right. Good. Perfect. Then all you do is the final charge of A is minus 2. The sign, once again, is very important. Minus 2. Okay, I know there are microcoulombs. I'll put the microcoulombs there later on. Then minus the initial charge of A was 1. Positive 1 minus plus 1. Very good. Then you do the algebra. That gives you minus 2 minus 1 is minus 3 microcoulombs. So that is the change in charge, right? So the next thing that you might ask is, how many electrons? Okay, let's look at A. What happened? It had a positive charge and it became less positive, or it even became negative. So it means A gains some electrons. So change in charge is, you can also call it charge gained or charge lost. right? So in this case, it gained a charge of -3. So to get the number of electrons transferred, that's the last question that they normally ask, you just simply divide your change in charge. This could be plus or minus. If it is plus, just divide by the charge on the electron without the charge. So that would be, in this case, -3 microcoulombs, which is times 10 to the power -6 coulombs, 10 to the power -6 coulombs. Then you divide by the elementary charge on an electron. This is also based on the law of charge quantization, that every charge in the universe is made up, consists of the basic elementary charge, the fundamental charge, the basic charge in an electron is minus 1.6 times 10 to the power -90. Yeah, this is. So from the formula, N is equals to Q over QE, or over E, over QE. And I hope you remember that formula. Then if you do the sum there, you get the number of electrons, just a number, the negatives will cancel. If it's a positive answer there, you have to check what the initial charge was and what the final charge was to see if it was charge gained or charge lost. That is all. So I hope this is very simple. Please share, subscribe, so that I can come to you again with more questions. I prefer to work more on questions, right, which I'll be doing a lot this year. Have a good day.